here. All right, cool. So thanks for joining, everyone. We'll be talking about crypto mining in your garage, and what is crypto mining and how can you get started. So a bit of a background. We did the introduction today, and everybody knows everyone right now. We'll be talking a bit about blockchain and technology and some of the background theories there. What is crypto mining? Before diving a bit deeper into how can you get started into crypto mining, we just had a discussion about one way to do some of the mining exercise, which is staking, putting some money in a wallet essentially and getting some rewards for that. There's other ways to do some mining. And then before even we get into all of that, we have to define what is mining, and then we'll be doing that very soon. And then we'll conclude with the discussion, just open and free, whatever we want to talk about. So a bit about me, data decision at Mindsets. I started Rogue AI as a meetup to just talk about technology and business because I'm super passionate about that. We covered a bit about you, and then this is super exciting to meet all of you here. So let's get started. I really like to frame the situation in any of those discussions in digital technology waves, and it helps to have this framework in looking at what happened since the 1950s till today. And if you think about computing, it started with the huge computers, the mainframe, which is like a building size kind of computer. Then you had like the client server PCs, those, think about your desktop kind of computer. Then you had the internet took over, you had Web 1.0 with e-commerce and Amazon in 1994. It's crazy, that's just 20 years since Amazon has been 25 years almost. Then you got mobile, and then like half, if not more, of people access the internet with mobile, which is amazing. It took over the world, especially with the iPhone and a lot of other technologies. And on top of all of this data that is happening all around, everybody's using and consuming data. You have smart people developing smart algorithms to analyze all of these data and to better serve you, better track you, better monitor you, better whatever you want using your data. So that is something that is happening, but not only in kind of, not just with humans and everything related to human activity, but also with machines. So machines now are talking to each other, and we'll talk about one example of such a machine. And you have things like the Internet of Things, where sensors are relaying information about everything that is happening around them. Think about your Ring smart home cameras, which can detect if you're moving or not and do an action, right? And then this is fueled by the artificial intelligence technologies that AI has been kind of going on for a while. I can do a whole session, a couple of hours of talk about the AI. It's not our topic now, but it is really the foundation and the big overarching theme that is driving a lot of these discussions. In parallel, you had that blockchain technology, which came up with Satoshi Nakamoto doing his paper about Bitcoin, a peer-to-peer electronic cash system. I printed it today and started reading it again after a while. And I was telling Sarah, I mean, this is a super smart guy, which unleashed $1 trillion plus of economic kind of investment value. It's debatable to how much of this is kind of a newly created wealth, but a newly created productivity and value economically. But it's a whole new market, right? And this is something super exciting, and we're talking about blockchain today. And on the horizon, still being talked about, you have quantum computing and then AR/VR/ all of these things somewhere there. But this is the technology space that we're living in. This is the tech space that some of your parents have seen, and some of what you're seeing right now, and then maybe some of what our kids and future kids will be seeing in the next decade or two. So from here, if you look at the history of information recording, started with clay tablet, papyrus, tally sticks, and a really big revolution happened with double entry bookkeeping. That's how Venice was built, the merchant, the Bank of Venice, and then people kind of trading and recording. Oh, you owe me like $10. No, you owe me $100 for this bushel of corn, for example, right? And then this evolved in nowadays in spreadsheets, Microsoft Excel, right? This is basically how we're recording information, huge databases. Another leap happened with distributed ledgers, and we'll be talking a bit about that in our definition of blockchain. So what is the blockchain technology? This is my own, if you want, dumbed down definition, just to simplify things, and I'll show you an example on the right screen right now. So blockchain is an incorruptible system of records, allowing us to program virtually anything of value. What does that mean? So I came up with this example, and then to simplify things, is your Excel database a blockchain? For example, you have an Excel file, is it a blockchain? Technically, it's not. All right, so what if my Excel database is synced on multiple computers, right? So it's like Google Sheet. I can open it here, and then I can share it with Emmett right now, and he can check and see the same information that I have recorded, right? It's alive on two computers. Is it a blockchain? Technically, it's not. All right, what if Emmett and I, both living like 2-3 miles away from each other right now, can also verify and agree on each entry together? So let's say in this database we have the content, which is the amount of that I have in my pocket right now in dollars. I have $100 bill. I put that information in that Excel database. Emmett can see it right now that I have $100 bill, and it shows on both our sheets, right? Is this a blockchain? Technically not, unless you tick this extra box, which is it's immutable. I mean, nobody can tamper with it, nobody can play and do anything with it, and nobody can just mess it up. So it's a historical record that nobody can erase. So now these are the key components of any distributed ledger blockchain technology. It has to be done. It's a database, it's basically information synced across multiple different computers. Everybody can agree and verify the value of what's inside, and nobody can mess with it and tamper it, technically speaking. All right, there's always ways to mess things up. But this is the basic foundation of what is blockchain tech. And then we'll get to cryptocurrency, but this is kind of the foundation that you need to know before you dive into, okay, what is this coin and what are we doing there? So with blockchain tech, how does it work? What I just explained before. It's basically ensuring the transfer of value between two different players. For example, let's say me and Emmett, I want to send him $10, for example, right now. How do I do that? I can just take $10, run to his house, and then give him $10. That's one way, right? Right now, for example, we have all of these Venmo and then digital cash transactions and all of that stuff, which is super cool. It's super easy, super quick. I can open Venmo, take his address, and then send him $10 using Venmo. So blockchain is a step above what Venmo is doing. How? It's because Venmo is passing through your banks and through the financial system that we have right now. And there's a system built in where somebody has say, okay, $10 from his account to your account, it passes through the bank, and then the bank approves of everything, and then it's done. What blockchain is coming and is saying, hey, instead of having just the bank, which is here in step 3 and then step 4, I won't have just one entity. I can have millions of people participating in this network and validating what is happening. So have all of these millions of computers connected, just like the internet, but they're doing something special. They're saying, oh yes, Emmett, Ali sent you $10, and I agree that this is true, and I'm gonna record it in my book that you received $10 from Ali. And then once that is recorded, you see kind of this chain here, it gets kind of tallied up and it's recorded, and value is basically transmitted between these two addresses. So that is what the blockchain is technically doing. It's a new fundamental way to transfer and distribute value in a way that no one can shut it down. No government can say, hey, you're blacklisted, or you're a terrorist, or you want to cut off the internet because of so and so and so and so. It's open. it's alive on millions of computers, and no one can just basically stand in its way. Now you have ways, now thinking about the internet analogy, the government controls the internet, right? I mean, they can basically say, like in Turkey, hey, we're gonna shut off the fiber optics, and then no one will have internet and block certain sites. Well, that is why peer-to-peer technologies like BitTorrent and torrent technology has been created in the past to bypass some of these restrictions. And it's another discussion, but that's something we can come back to. So where does cryptocurrency mining fit in? So remember me sending $10 to Emmett and through this transaction. Well, somebody has to validate this transaction and say, hey, yes, I agree, this is what happened. Maybe Fletcher will come in and say, no, it's not $10, it's $5. Who's the arbitrator here to say that this is exactly what happened? So that is why mining is an essential part of the whole equation, because the job of mining and these miners is to validate this transaction that happened on the network. And we'll talk about how does that happen in a technical way. But remember here we had all of these people, all of this network. Then we have a transaction of value between these two nodes, A and B. And then you have somebody giving that check mark here. The people who are giving the check mark on the transaction that happened, they're called the miners. Okay? And then these people, basically, they're just like, it's basically a computer doing the work and verifying everything. And then in exchange for the verification that it is doing, it's getting a reward. All right, so this is cool. We have some of the foundations over there. But what is Bitcoin, Ether, and like ADA, and then all of these other cryptocurrencies? So all of these projects, they basically made use of the blockchain technology that we just explained to create something of value. And most of these projects, they're kind of digital currencies. A lot of them, like Bitcoin is and wants to be. Ether has a lot of different applications, not just as a currency. It wants to be the new way to power all of these applications and exchanges of values where you can build applications on top of that with Web 3.0. We can talk about that later. And then the amazing thing, if you look at Bitcoin, and then that it reached like $1 trillion in value. In what? In 8, 9 years, 10 years, which is unprecedented for anything that ever created by any human or by humans. It's like the fastest thing that ever grew to $1 trillion. And if you contextualize wealth in the world right now, I mean, cryptocurrencies. I mean, in September 2018, they were about $202 billion, all cryptos. Right now, as of March 2020, when I built this, it was around 1.7 trillion. The whole Apple is like around 1 trillion. All the money in the world is around 86 trillion. So I mean, you're seeing that this is something huge. This is something big. You have roughly 1-2% of the money of the world put in something called a cryptocurrency. Right? So it's not something that anyone can discard anymore. Coming back to miners, the people that are verifying the transaction between me and Emmett, right? And then why are they doing it? Well, a lot of people are doing it for the money because it's a lucrative business. For example, in January of 2021, Bitcoin miners made around $35 million in revenue, which is a lot of money in a month, right? And if you look at the graph here on the right, you notice a direct relationship between the blue graph, which is the price of Bitcoin, and the red bars, which is the revenues the miners are making. There's a kind of a correlation. I mean, when Bitcoin price rises up, miners seem to be making more money, right? All right, so what are miners exactly doing to basically get that reward? I wanted to get a bit technical because I mean, so you can understand exactly once you're building your mining rig, which we're gonna talk in the next 10 minutes about how to build a mining rig. You know what your rig and your computer is doing, right? So you understand a bit some of the tuning and the performance issues that you might run into. So what I'm gonna talk about applies to proof of work. And proof of work is one type of algorithm used to verify the transaction that is happening between two transactions happening on to be added into the block. All right, so it's a blockchain, right? So there's millions of transactions happening, and they get recorded and they get registered on this block. Now, before this block ends, and then the verification needs to happen, so we basically lock that block and then file it and say, okay, this is a true transaction of everything that ever happened. The verification process needs to happen, all right? This verification process is called mining. And what is mining? It's basically a calculation that is happening to be able to stamp and lock that block. All right, so I'm going to talk a bit about how does that work, all right, just to give you a kind of an idea. So if you're in the cryptography world, there's something called the SHA-256, and what you need to know about this is basically it's a function, just like 1 plus 1 is equal to 2, which is a function you learned in school. It's a function that does something. What does it do? It does a very special thing. Whatever set of variables that you put into that function, let's call this function SHA-256. I think that's how they pronounce it, right? SHA-256, and then of 1 you'll get an answer, right? SHA-256 of 17 you'll get an answer. SHA-256 of whatever text you'll get a different answer. It has a unique property of being a one-way function. No one can reverse engineer it and find from the output what is the input. So this guarantees one thing, that whatever you put into here as inputs will give you one and unique output. So in the design of the algorithm, how is this used? You take some of the signature of the previous block, you take the signature of all of these transactions, you take the timestamp, and then there is one unknown that is left. All right, what is this unknown? That unknown is used in the calculation and varied in your computation as a miner. Your job is basically to find that nonce, that unknown, to be able to match the difficulty of the network. I know I'm throwing a lot of terms here, but so blockchain and Bitcoin will have a certain difficulty that varies depending on certain variables. And then your job as a miner is to find this number in pink here that is matching the difficulty while running this very expensive and energy intensive and complicated puzzle function that you're seeing here on the screen. And that's exactly what you're doing when you're mining Bitcoin and a lot of different other coins. We can get into the details later in the discussion, but I will stop here.
But because the work is so hard, this is what makes sure it's secure.
Yes.
Because you have to work pretty dang hard, which means
That's right. In the early days, Fletcher, in the early days of mining, you could mine with your CPU, for example, Bitcoin, and then those were the lucky days, right? It's like the gold rush. Now you never dream to do that because it's super computationally intensive and difficult. It's a super hard equation that you're seeing here on the screen. It's super hard to solve at the current state of Bitcoin, and it's gonna get harder and harder the more the currency grows.
Which secures the higher and higher value, makes it safe.
Yes. So miners are solving a very difficult equation to validate blocks. So if you look here at, so this is the equation they're solving to do the transmission of the $10 from me to Emmett. All of these nodes are getting registered on this block, and all of these transactions happen. And you have the miners running the function I just told you about and saying, okay, I verify everything that happened. And then once one of the miners find that number that clicks and and it clicks and locks the locks on the locks. Lock the locks on this block. So what happens? It says, "Hey, I found the block. I found the key to the block to lock it, and then verify all of the transactions. I broadcast it to everyone. All of the computers on the network, they take that key and then try it. They found that it's okay, and they all give kind of the check mark. Yes, that's the correct answer." And that's what happens, and then it propagates across all of the network that yes, all of these transactions happen. We verified all of these transactions using that key that you found as a miner. That's why your role as a miner is super key and essential, and we can talk a bit more about decentralization and some policies and all of that later on. And then once that happens, well, what happens basically, you get kind of added to the chain, and you're another block in the chain, right? And the process repeats itself. Some comments about this process is you get rewarded once you find that key. And typically it's super hard for you as an individual with limited computing power to find that key. So what happens, Fletcher has a computer, I have a computer, we join forces and say, "Hey Fletcher, let's join our computational power together into a pool, and then let's try to crack and find that key, that puzzle, and solve for that key together. And once we find it, we split the profit together." So most miners, especially small miners like you, if you want to do it in your garage, you're gonna be joining a pool and sharing profits with other people. So that's one comment. Another comment is proof of work is super energy intensive. You need to think about it. That is the beauty, and then the compromise of Bitcoin and some of these cryptocurrencies, is you're paying for that digital transaction with energy. And energy is expensive. It has a real effect on the environment. You can see it, right? It's what is heating you up. It's what's lighting your room, right? And then there's arguments in the community about the pros and cons of this process, and then we can talk about them. So ADA, Fletcher was speaking about ADA, and then ADA is a proof of stake. It's saying, hey, I don't want to solve this super intensive, computationally intensive kind of puzzle and use a lot of energy. Basically, Bitcoin uses energy as much as a couple of countries together. I forgot the number, but it's a lot of energy.
Yeah, it's recently like Argentina now or something.
Argentina.
Oh no, that's all proof of work. Sorry, it's Sweden with just Bitcoin.
Yeah, Sweden. So Bitcoin only, just validating all of these transactions, me sending to Ahmed sending to somebody else, is taking as much energy as Sweden. There's some good thing about this, and then there's some framing to be done to see, okay, what should we compare that to? So how much is the global transaction economic system and transaction and banking system using in terms of energy, right? Compare that to Bitcoin, because it's essentially doing the same thing. It's essentially replacing the guy who's the teller at the bank, turning on his computer, coming into the shower, in the bathroom, in the morning, at the gym. All of these economic energy footprint should be taken into consideration to be able to do a comparison.
Or the environmental cost of mining gold, how destructive that can be in certain places. You have to look at the whole supply chain. You can't isolate and say, oh, Bitcoin is doing this, but hey, I can I swipe my Visa card and do the transaction. Okay, what is the cost of the Visa system, right? So you have to look at that on a system perspective. So proof of stake, on the other hand, is saying, hey, I don't want to pay energy to validate and run this computationally intensive transaction. What I want to do is stake some of my money. And what's the dearest thing for people with money? It's their money, right? So you say, hey, I have $100. I'm gonna put it on the network, and then the network is gonna keep it for me as a guarantee. Think of it as your mortgage, like you're mortgaging, like your house that you have, right? We all have a stake in the current financial system.
Yeah. So you don't wanna mess up kind of your house, right? You don't wanna do something that will diminish the value of your house. You want it to increase. It's the same thing. So the guarantee for you to do this job of validator, to validate the transactions that are happening, is whatever you stake into the network. So you don't want to mess up the network and ending up losing your stake that you have into it. So that is the consensus kind of algorithm that is being built as an alternative to proof of work. So for our purposes today, we're going to focus a bit more on proof of work and then some of the mining stuff that you can do, some of the mining algorithms that benefit from mining with different hardwares on some of these proof of works algorithms. And some of the top mining algorithms are, we talked about the SHA-256, and I just found out today it was originally created by the NSA, which tells you something. ETH-hash, which is basically Ethereum, one of the very popular algorithm. It is very resistant to ASICs. We'll talk about ASICs in a few. Script, which is powering Litecoin and Dogecoin, marketed by Elon Musk in his tweet, and it kind of goes up in value like crazy. X11, another one, GPU mining friendly. Equihash, Zcash, which is powering Zcash, powered by, it was designed initially by academics. There's a lot of different algorithms, but these are some of the most popular ones. So this concludes a bit our first part, basically the theoretical part, foundation that you need to understand and get into mining. But I mean, you can take that and put it aside, even if you didn't get anything about what we just talked about, Bitcoin and blockchain and all of that and how it works. And say you're a normal dude or lady and you want to get into mining and try to make some money maybe, or because you're a believer in one cryptocurrency project like ADA and you want to support what they're doing. So how can you get into that, right? We're going to talk a bit more about some of the practical aspects of things.
I'm going to make one comment about,
yeah.
I think, and maybe this is already obvious to everybody, but I often share this. I mean, it's no small thing what was accomplished, because kind of like with our current financial system, we all have a stake in it. That's why we're all pretty concerned when governments, institutions don't seem to play by the same rules, or they change the terms and conditions on us without consulting us necessarily. And what's so amazing about this is we go, okay, well, we gave you centralized custody of this thing that we were all supposed to be the trustees and benefactors of, and then you change the parameters. Well, this is saying, well, fine, we'll decentralize it in a way that doesn't allow anybody to change the parameters on everybody. So we get to agree on the terms and conditions and maintain that. So that's where it's worth it, or at least from those of us who kind of this perspective of like, yeah, we don't need those intermediaries, the regulators, and all these other pieces. It's kind of the philosophical piece.
I love the philosophical implication, this socio-philosophical implication of blockchain and cryptocurrency. I think we should do another set of discussion just to discuss some of the governance and socio-economic implication of blockchain. There's so much that can be done to apply this technology in every aspect of our social exchanges that we're having. It's super exciting.
Revolutionary.
Yeah. But getting back to greed and then money. And
or sustainability.
Yeah, or sustainability, or generating passive income, financial planning. I think you should, before you do any of you jump and then say, I want to get into crypto mining, you should ask yourself these questions. Why are you interested in mining? If you're just kind of here for a quick buck and quick money, you should know that, and then know some of your decisions that will be that will follow up based on that premise. Or you're a believer in a project, let's say you're very interested in the Bitcoin project and you want to contribute somehow, that might offer you a different set of follow-up decisions that you might be making. What is your time horizon? Are you doing this for 6 months, a year, 10 years? What are you committing here in terms of times and resources? Budget, is it like $1,000 to get a small mining rig, or is it less than $10,000? Is it $100,000? And we're still talking here about the garage kind of scenario. I'm not talking here about opening a business and then setting up a mining farm, because they can run in tens of millions of dollars, at least right now in the current market that we have. So it's good to have a perspective there. And then last question is, how tech savvy are you? I mean, are you just, do you know how to type and then do Microsoft Word? Are you rank yourself here? Rank yourself on the scale of internet user, PC builder, hacker. You're somewhere here on the scale. I consider myself internet PC kind of builder. I'm very comfortable with some of these technologies. So the more comfortable you are with technology, software, and then computers, the easier it's gonna be for you to put something together and then understand what's happening. But don't worry, if you're not, you can find some other people to help you. You can find some other alternatives, and we were talking about that. So what follows is basically the steps I'm going to outline next are mainly for people who are in this a bit for the long term, not the short term. And by long term, I mean more a year plus, 2 year, kind of 2 year plus. That's what I'm meaning by long term. You can be in this forever, but I mean that's the term. And budget really like up to a $10,000 budget in terms of establishing any mining rig. You can do a mining equipment with $500, but you can go up to $10,000, and then I'll show you there's some people doing mining rigs for hundreds of thousands of dollars, building a shed and going crazy on tons of different things. And then tech savviness, you don't need a lot of tech savviness, but at least you should know how to Google and then use the internet. I mean, that's a basic. So options that you have, you can use your own computing hardware. You can rent existing computer hardware, like a server farm with somebody who has some mining equipment. You can pay to rent some of that equipment, and essentially what you'll be doing is buying that coin and currency at a discount because you're not doing any of the operation. That's something to think about. You can use your money to mine with proof of stake coins instead of doing all of this hardware stuff. Ada, you're saying there's some hardware involved, so some of them might have some hardware involved.
Or bare metal, server type systems.
For today, we're gonna focus on saying you want to take the route of running your own computing hardwares, right? And then some of the options, high level, you're looking at this. You're looking at ASICs, which are basically supercomputers in a box. You want to think about it. It's a very smart supercomputer who can do only one thing and one thing very well and doesn't do anything else. It mines Bitcoin, for example, or it mines a certain other coin. And typically these run in tens of thousands of dollars, or 20, 25 even. You can find some used one and old generation ones for $500, $600, but they're loud, they're noisy, they use a lot of electricity, they're hot, and they won't be super efficient, and then you're just limited to one or two coins, one or two algorithms that they're specifically designed for. GPUs are the more flexible option, and then this is the one we'll be focusing on today. Expect to spend, if you're going that route, around $1,000 plus to build a mining rig with one card, for example. And then we'll talk about the details next. And then this is what it looks like if you have 6-7 mining cards together. CPUs, in the old days, you used to be able to mine with CPUs. Right now, CPU is basically your laptop and your computer. It has a CPU, right? But you can buy a pre-made desktop, which is a CPU, and mine with it. Or some people have been mining with Raspberry Pis. I mean, and just these small little computers, and you just put them all together, and then he does a super cluster of Raspberry Pis. It's funny to watch. And then you can make some money there. We'll talk a bit about some of the economics next. What is not shown here is some other options like helium. The helium miner. Helium is basically a network. We won't talk about it in detail, but I'm just throwing it here to tell you that there are other options. Not shown here, but these are the most popular one. Other super inventing project like helium, and basically what they did, they found a way to incentivize people to deploy a radio network. by giving them money. And it's amazing because right now people are creating and deploying their own radio network. And soon the next iteration of this is people deploying their 5G network, which is crazy. We just got 5G. And imagine people buying these small radios, I mean they're just like tiny, putting them in their homes, and then just by the fact that they're powering them on and they're connecting them to the internet, and they're allowing the exchange of data through these different radio network, they're participating in this blockchain network to transmit data, they're getting rewarded, and then they're getting rewarded a significant amount of money to make it interesting for them to purchase these equipment and deploy them in different places. Here in Medford we have I think dozens of helium miners already, Grants Pass, Ashland also, and then if you go into bigger cities, I mean it's like totally covered. I can show you some of the networks there. So just to say that there are other options, but these are kind of very specific individual projects with which are super interesting. All right, let's have a look at the macroeconomics of things. Let's say you have $1,000 today, and then you're interested in buying a video card to build your mining rig to be able to mine. What you'll find is I built this chart and then posted it on, while doing my research, and posted it on Reddit to collect some feedback from the community, and then get some really good feedback. For example, if you have around $1,000, you can maybe buy a 6700 XT. I know you can see it from that far, but 6700 XT, and you can expect a break even of around 240 days after you get some of the rewards, and then you pay your electricity. That's what you can expect. If you look, for example, at the 3090, which is currently around $2,700, you're expecting around the 320 days of mining to get your money back.
More expensive isn't always better.
Yes, and it depends on a lot of things. This chart plays well with the second one, which I'm going to show you. And some of these numbers, I mean, don't take them as kind of set in stone, because this is a very fluid thing. Prices changes every day, profitability changes every day. Just to give you a comparative benchmark between equipment, and you have the older first generation equipment, which are cheaper, getting cheaper, and then since mining is so profitable right now, I mean, some of the break even for them is super low. But the newer equipment here, for example, the third generation NVIDIAs, like the 3070, 3080s, they basically get you more money, but it takes a bit while to break even sometimes. And then this is shown here with the profitability on the y-axis and the mining efficiency in watt per megahash second on the right axis. So for example, the lower number here is better because it's giving you some computational power at a lower cost of electricity. So the 3070 here is great, right? And it's giving you around, at the time I built this chart, around $4 point something of profit a day, which is, wow, oh, right, $4 a day times 30, that's $120 if you have one of these. So, I mean, that's how a miner thinks, $120 per card. And then I paid for it, if you go to the previous chart, the 3070, I paid for it around $1,200. So I'll probably pay it off in a year. All right, great, and I'll start making a lot of money. What if I have 10 of these? I'll be doing, 100 times 10, $1,000 of passive income. I can pay it off in a year, and I can still make money later on. So from these two charts, you see why mining is drawing a lot of people trying to understand the technology and trying to make some money out of this technology, right? And then this chart gives you kind of an overall look at which equipment is more efficient to buy, and then will make you some profit. So I'm not giving any recommendations today. I'm just kind of showing you the information. We can talk about specifics later on. But after you looked at some of the equipments available out there, you can look at, okay, what are the top profitable coins to mine, for example. And then let's say you picked your 3070 GPU, which we said costs around $1,200. And then you can see here, if you're mining with a 3070 GPU Ethereum, you'll be making, I just checked this today, around $4.9 in revenue. And if you're paying 10 cents per kilowatt hour of electricity, you're making around $4.6 of net profit for you, which is pretty sweet, right? And then the beauty of GPUs is that you can mine other stuff with them. You can mine Ergo, for example, Flux, Equilibria, Swap, Rio, many other coins, which you can do in ASICs and other technologies. And then if you want to check this, What to Mine is a super cool website to go through all this. All right, now that you're super excited, and then I got your interest with how much money you can be making with this. I mean, there are some YouTubers which are in this thing, and then they have their whole basement filled with mining rigs, and they're making tens of thousands of dollars a month from mining. I mean, that's how far you can take this. And then ongoing investment into mining hardware, and then just kind of keeping up with everything. So three steps: you buy hardware, you put things together, and you operate and manage your rig. Okay, let's go through them step by step. What is the hardware? What are we talking about here? If you have ever built a computer before, you would be familiar with a lot of these things. If not, it's okay. It's not that hard. All of the information is out there. But what you need basically is GPUs. That's a 3070. That is the piece of electronic that will give you around $4 a day, which we just talked about. Then you need a motherboard, which is basically the electronic thing where you plug things together, like your GPU, and then some of these other components. So you need your CPU, which is basically the computer, the head, the brain of your computer. You need some memory, which is an SSD. You need some additional temporary memory, which is a RAM, and you plug it in here. And then you need a power supply. These are some of the key components here. And then if you're looking at costs, for example, we looked at the GPU, which is $1,200 right now in current market prices. I forgot to tell you that this is mean retail price times 2, because when Nvidia released this, it was around $600 or $700, but since mining is crazy, everybody is buying some of these GPUs, and then the price is shooting up, and then you can't find any in stock. So it's a bit of a whole separate discussion how to procure some of these GPUs, but they're out there. Like a CPU, a new one will run you around $120, $150, an SSD maybe $50 to $100, RAM around $50 to $100 depending on what you're getting. Power supply, a good one, around $120. So right now the most expensive part is around the GPUs because of all of the crazy mining stuff that is happening. So once you bought the hardware, there's a lot of different guides on how to put them together. I won't go into details on how you do that, but once you put it together, it will look something like this. It's sitting on a desk. You have the power supply, the motherboard, the GPUs, and all of the stuff inside connected. And then the nice thing about now the ecosystem is becoming easier and easier to get started. You don't need to go into complicated installation. There are people who have built a specific mining operating system. You just kind of install it on a USB flash drive, you stick it into your motherboard, your computer, and then you just start, and then there you go, you're ready. You don't have to do a lot of fiddling and getting ready your rig. So now that you have your hardware kind of put together, and then your operating system kind of ready and then running, you have to kind of learn how to use the mining operating system. This is an example of Hive OS, the one I just told you about here, and I have a guide linked here. And what you can do with that is you go in the software, and then you can choose your miner's program that you want to mine. I'll show you one of them on my laptop today. You can choose the coin that you want to mine. We saw Ethereum is the most profitable one right now, so you can choose that. You can choose the mining pool, which is basically, remember I told you Fletcher and I will join forces together so we can have a better chance at getting the key which solves the puzzle. So that is what I mean. There's some mining pool that you can bond with and then join. You create a digital wallet, so once you mine, you get paid into that wallet. And then the not so fun part is the continuous fiddling and tuning of the cards, because every card is different and a lot of different settings to be able to adapt some of these cards so they operate at maximum efficiency. But hey, we're almost there. Now you can just run your miner and start kind of making money, and then constantly kind of checking how much you're making and all of that. So for example, you're now contributing, if this is your address, this is the pool that you're working with. This is, for example, ETH miner. You can see how much you're contributing in terms of mining hash rate power, and then how much they're accepting your contribution, and then how much you're getting paid in terms of rewards against your contribution. So yeah, so this is almost it. To show you how a miner runs, just to give you an idea. I think this meeting has ended. Oh, because I ended it in an hour. Shit.